Okay, so this is Andrew, Eric, and Kyle's lesson study. It was in Pre-Calculus 20, and the lesson was on absolute value. Okay, I'm going to go through the original lesson quickly here. Alright, so this is the first time absolute value shows up in the curriculum, so there's not really a lot of prior knowledge, so I didn't really go into that in the original lesson. And our general outcome was to demonstrate understanding of the absolute value of real numbers and equations and functions involving the absolute value of linear and quadratic functions. And yeah, the prior knowledge that we did come up with was students should know what a number line is and have a basic understanding of functions prior to the lesson. Okay, my essential questions that I had were: how does the distance of n from 0 compare to the distance of negative n? How does the absolute value of n compare to the absolute value of negative n? And what do we know about the range of the absolute value of a function? Alright, so the lesson itself. My set was, I had to teach this to 2 people as opposed to a full classroom, so I kind of modified it when I actually micro-taught it. But the original plan was to give a student like a plus sign, like a piece of paper with a positive sign, and a piece of paper with a negative sign, and hold it on either side of his or her body, and explain to him or her that there's 0 on a number line, and then I'd have other students walk on either side of the student and describe their position relative to 0 and their distance to 0. And they were supposed to come to the realization that their distance is always positive, and then that would be establish the definition of absolute value. And then from there, I would kind of jump into the definitions of absolute value, and then discuss, solving some equations, whether it be, x equals the absolute value of something, or when x is inside the absolute value sign. And kind of a way I thought to assess the students during the lesson was to have students come up to the board and answer a question that I had posed, and then kind of have other students give like a thumbs up or thumbs down if they understand or not. And then for closure, I just kind of did a quick little review of the concepts. And then I was going to have a handout. I didn't actually type one up, but a handout that would be done to just kind of check for the understanding. So yeah.
Alright, I'm going to talk about what we changed, or what we liked and what we changed. So the first thing was, we did not like Kyle's adapted dimension because there was none. So we went and we modified that. So we put, for students with who are visually challenged, we would use manipulatives to assist their learning. Also, manipulatives can be used for other students that just need to have a little more practice with the concept. We also put, for those with hearing loss, instructions will be given facing the class. We could also use a microphone or a translator if necessary. For students in the top 1/3, the assignments would be changed to make them more difficult and more challenging. As well, for students who struggle, we may have to modify the assignment to their level. The other thing we changed was the performance task. So originally, students were to receive a sheet at the end of class to complete as homework, but not graded. We changed it to given a question sheet to assess their understanding, and students will be given practical application situations to develop their understanding further. As well, the further other evidence, Kyle had that they would be showing their thumbs up or thumbs down to see if they understood what was going on. But this isn't a very good way of really knowing whether they know what they're talking about, because if one student puts their thumb up, chances are the other students will follow. So we changed it to a discussion where we would observe what the students were saying and whether they knew what was actually going on.
Alright, so we also decided that we liked Kyle's set. However, we didn't like the small version of it, so we decided that if we were going to teach it in a classroom, we'd want to do it on a bigger scale, and we'd also want to assess their prior knowledge on number lines before we got them into the set, because if they don't know what a number line is, they don't know what an integer is, it would be kind of hard to develop the understanding of absolute value. So we decided after we assessed the knowledge that we would take the students into the hall where we have taped a number line on the floor. Then we would have one student holding the signs like Kyle had originally, but then would have more than one student walk on the line, and then they would compare their distance from the original start point to one another's and realize, yeah, their number on the number line is different, but their placement from the person is the same. Then the last thing we talked about was we liked how Kyle went through the comparison of functions. So he went over the comparison in graph form of a function and then the graph of its absolute function and compared them over top of each other. We thought this would be a good way for students to visually compare the two and realize what an absolute function does to and we thought that it would be very, very good for students who don't actually understand maybe the number line concept. They might understand the graphical form more. And to conclude, basically, we decided that Kyle's lesson was very well developed. There were just some things missing and some things that could be taken a little bit further to access deeper understanding. For example, when we were assessing the prior knowledge in the set, we took that a little further just so that we knew that the students knew what a number line was and an integer was before we got into absolute values.